Hello and welcome to this week's What Were They Thinking? Among the news items we have for you this week is a novel vaccine for malaria, one of the less well explored diseases out there. Then there is the various announcements regarding polio throughout America and how its increasing presence and impact is being felt. How fungus will change its shape physically to be able to get deeper inside your brain and do what it wants to do. There are also various other bits of pathology-related news that are also less than encouraging. The novel 3-parent embryo reveals some safety concerns, and the winners of the 2022 IgNoble prizes. The timestamps for these and other news items can be found in the description box below. Considering that from the occurrence of COVID-19 to the release of a vaccine, we waited maybe 18 months overall. The fact that many malaria vaccines have been in development since as early as the 70s, you might be surprised. This is for two reasons. First, and perhaps foremost, much of the work for COVID-19 vaccines was already developed. Things like mRNA technology for vaccines was established and in the pipeline for other applications. COVID-19 itself is a relative of SARS, and there was work on vaccines for something like that as well. It meant it was much easier to try and pathway into a COVID vaccine. This created an ideal combination of delivery mechanism and known pathogen. Malaria, which the current vaccine we're about to talk about relates to, isn't well understood, and there is currently no especially effective delivery mechanism available for it. The reason for this is simply that we don't know where to target on the malaria parasite itself. The most common treatments at the moment are quinine related, and these help by targeting the malaria in a particular way, a way that we haven't been able to use a vaccine to do since. Malaria being endemic to a number of areas, but especially in Africa. Parts of Africa have even developed certain other pathologies to compensate and give individuals an advantage in resisting malaria. Sickle cell anemia is a particular example with that in mind. Treating for malaria would obviously create problems for those individuals in that they would no longer be top of the food chain, but you would also be able to hopefully help those individuals who aren't sick at all not have malaria, so you have to look at it that way. The vaccine, which is now called Mosquirix, had 68% efficacy over 6 months post-administration of the first 3 doses, but it did decrease over time. After a 4th dose at 18 months, the vaccine was 44% effective. So no, we're not talking anything earth-shattering here. In fact, it's well below what most vaccines' efficacy is going to be. Your annual influenza shot is about 90%. COVID-19 shots were anywhere upwards of 90%. So this is not great, and certainly well below targeted goals of somewhere at 75 or higher percent. Despite that, keep in mind that every vaccine that's administered will reduce the likelihood of dying from malaria, so take it as you will. It's not as though it's going to cause any harm, but it may save 44% of the individuals who would otherwise have died. Later work went on to build on this initial vaccine, and the most recent clinical trial, which is the impetus for this video, shows a 75% protection over 24 months after the initial vaccines were given. The catch to this significantly better efficacy is who the vaccine was given to: children aged between 5 and 17 months. That is one of the groups that is most vulnerable to infection from the malaria parasite. There's a certain irony in how hard it has been to get rid of malaria, especially given that, say, countries like America specifically made the CDC to get rid of it. They succeeded. America is, for all intents and purposes, free of malaria, and it's not the only disease they've managed to get rid of. Tuberculosis is gone, and so was polio until relatively recently. It's resurging, and resurging because people are frankly being stupid. There is no rational reason why you should unnecessarily not have the vaccine for polio, which does provide protection. Admittedly, it's not universally provided, but it's provided enough and accessible if you do want it. This means that people coming back from other countries where they generally pick it up and then bring it back and expose others to it do so effectively where they could have otherwise avoided it. New York has been especially bad for these sorts of diseases. It was previously measles, and with now polio, it's so bad that New York's governor has had to declare a state disaster and emergency. 5 of their counties are that badly infected. It's ridiculous. The spread isn't just something random, which is unfortunate. It is spreading via the community, which means it's people interacting with people who are infected and taking it around that way. Now, if you're an adult, chances are you may not have any particular notable results of being infected. However, if you are a child, things are very different. As with malaria, where it can kill children, it can be that severe with polio, but polio is more likely to cause paralysis and permanent paralysis in some of your lower limbs. Understand, polio isn't that prevalent, at least across the world. Most countries have taken this pretty damn seriously and have managed to, if not eradicate it, isolate it to extremely small areas. There are only a few countries across the globe that A, still have it, and B, are on a list of polio countries that the World Health Organization runs, and the United States has now been added to that list. They are in the company of Israel, the UK, Pakistan, and a few other low and middle income countries. These were previously described as third world countries. Yes, the UK, USA, and Israel have joined the list of third world countries with polio. Some of the other countries that America is in the company of include Ethiopia, Mozambique, Somalia, and Yemen. These aren't exactly the highlights of the world, so to speak. Certainly nowhere near as populous or as well off as America, UK, or Israel. And yet it's joined their company because polio is spreading and effectively in the wild now, and that is one of the concerns that has been raised. The problem with what's happened is twofold. One is that people aren't vaccinating. Some areas in New York are as low as 37% vaccination rates. Further to that, the use of 2 different kinds of vaccines. One is an attenuated vaccine, or one that has been weakened, and so that this stimulates an immune response that will resist against the polio that causes paralysis. The other vaccine option, which is generally more common and popular, is inactivated polio. That is polio that has been killed, leaving only the necessary antigens, or sites on the polio, for the immune system to be able to recognize it on subsequent exposures. There is no live polio virus at all. It is simply the broken up bits of the virus. Much in the same way you cannot reassemble a scrambled egg and hatch a chicken, you cannot reassemble the inactivated polio virus and become infected by it. The live attenuated virus, slightly different. If there are not enough people vaccinated against it and you use the attenuated virus, then you wind up in a situation where yes, you can theoretically get the attenuated version spreading from person to person. It generally doesn't cause any harm until it begins to mutate. For the most part, this is why US and other countries moved away from using the attenuated polio virus, that's the oral polio vaccine for the most part, and went with the inactivated version. This way there was no possibility for it to become, in any way, shape or form, spread. However, some parts of the world do still use it, and as a result, you do wind up with people still carrying it for various reasons. It's not just polio that is a concern. There are all kinds of microbes out there that at one point or another are trying to kill you. For the most part, you'll never know that they've tried. That's because you have an immune system that is quite good at dealing with these things. Conversely, there are some that will slip through the gaps. HIV being an example of this. It's managed to find a kink in the immune system and has exploited it exceptionally well. One part of your body that is exceptionally well protected is the brain. Not only do you have an active immune system outside of it patrolling for any kind of pathogen, you have the blood-brain barrier, which acts as another preventative measure, and then there are immune cells inside the brain itself. All of these layers of defense prevent things from getting in there and then having their way if they do succeed. that is, except for a few exceptions. One of them is a fungus, Cryptococcus neoformans. What it does, and it's kind of interesting in how it does it, is that it changes its size to better get into the brain. Once it's in the brain, it can then return to its original size and start causing you problems. The nature of how the body and the immune system generally deals with infections means that you get swelling in the brain, and it's a condition called fungal meningitis. This inflammation and then swelling is an attempt to allow the immune system to get in and deal with the infection, but at the same time, the brain is locked inside of a hard bone case, and extra pressure from that swelling is not good for you. The fungus in this case is thought to have acquired its particular traits as a result of how it infects other species. It generally comes out of pigeon poo. The pigeon poo is very high in phosphor, and this is something that is thought to make it more capable of hijacking parts of the human body once it's infected. The infection often comes from inspiring or breathing in the fungus. When it's breathed in, when it occupies the lungs, it's quite large. Once it gets into the bloodstream, it's substantially smaller, and when it gets to the brain, smaller again. As has been said before, it's often an arms race between the defensive abilities of our immune system and the weapons of our pathogenic organisms that we are fighting against, like this fungus. Not all fungi are the cause of our demise. In fact, reality is that most of what's going to kill you is probably going to be either a virus or a bacterium, and there's a better chance it's a bacteria. Bacteria can be found everywhere. Viruses need a host, and that's why the current outbreak of monkeypox is a concern. It's spreading quite quickly, and it has pretty much hit every major country, or at least every developed country that has been keeping accurate records. This is why the first death associated with monkeypox is a worry. The LA man died of monkeypox, but it's not just the monkeypox itself. It's because they had a severely weakened immune system. In a similar way to COVID-19, the people who are most at risk are either going to be extremely elderly, extremely young, or immunocompromised. The last group are ones unable to mount a defense with their immune system for a variety of reasons. Whether they've received organ transplants, they have autoimmune diseases, they're currently receiving cancer treatment. There are a bunch of ways that it could be caused, and the reality is that the more monkeypox spreads, the more there's a good chance somebody who is immunocompromised or similar will be exposed to it. At present, there are at least 58,000 cases of monkeypox across the globe, and pretty much all of them have been found where it should not be found. Going from pathogens to experimental fertility treatments. Specifically, the baby born in 2016, the baby had 3 parents in that there were 2 contributors of DNA and a third donor who provided the egg. The procedure was entirely experimental, and it involved taking the donor egg, removing the DNA that was in it, adding the mother's DNA into that egg, and then using the father's sperm to fertilize it. This should have worked in theory, and it did result in a birth. The experimental method was used for one simple reason. They were trying to avoid a heritable condition, a neurological disease called Leigh syndrome. This is passed down through maternal mitochondria. By using a donor that's not related, and therefore all the mitochondria within the ovum aren't from that lineage, they could completely skip the issue. Genetic testing of cells at the blastocyst stage found that yes, this does work, and that there were no obvious signs in the genome or any of the other genetic material that it would in any way, shape or form happen down the track. The technique used at that time transferred less than 5% of the mitochondrial DNA from the mother whose DNA was transferred. The more modern techniques, if you want to use that word, bring that down to about 2%. So again, significantly small chances of any one of the possible diseases that are associated with maternal mitochondrial DNA can actually have an impact on those individuals. and it's why a number of countries, although it is a very small number, have legalized mitochondrial donation, going from scientific experiments on fertility to the ability to create cancer therapies in your own body, or at least in the body of rodent models. The idea here is to be able to implant a small device within the human eventually, but currently mice, that would produce the drug locally. The idea simply being that by making it within the body, you no longer need to give them a large dose of the drug, which circulates everywhere until it eventually finds its target, but also you can localize it to the issue, generally speaking, cancer. The way it works is relatively simple. You remove the majority of the cancer as it is if possible, but if not, you simply put the device that puts out interleukin-2 into that tissue. Interleukin-2 is a stimulator of the immune system. It tells the immune system to start targeting whatever is in that area and destroy it. In this case, it would be cancer. The caveat to using interleukin-2 is that it does stimulate the immune system, and you want that in that area. Targeted application is good. Not targeted application, like for example with the brain fungal infections, can lead to inflammation, both locally and systemically. That can create problems and can lead to the body being targeted by the immune system. So you want to aggravate the immune system enough in that area to attack the cancer, not so much as you activate it across the entirety of the body. This is why being able to target and deliver it to that very narrow region where the cancer is a really big step. It is a very targeted, very precise, and very limited treatment that avoids many of the problems that we currently observe with other treatment avenues when it comes to things like chemotherapy. It's that kind of evidence that's really important, especially when you're talking about any kind of clinical treatment. Note, it's evidence-based. That is very different to what TikTok chiropractors are doing. They are claiming that you can help your infant or baby stop crying and making a fuss with chiropractic care. Given that chiropractors talk a load of crap at the best of times, this seems even more nonsensical than usual. But, giving the benefit of the doubt, perhaps they have some particular advice that is not based in chiropractic practices. But no, they're suggesting adjustments. Adjustments are the kind of thing that have led to adults having strokes, people with broken necks, and in some extreme cases, death. Not something you should be giving to any kind of baby for any reason. The fact TikTok doesn't crack down on this nonsensical shenanigans is worrying at the best of times as well, but it's TikTok. You can't exactly expect anybody to be talking sense on that app. The problem with chiropractors as a whole is a lack of, first of all, clinical evidence, and B, reviewed evidence that involves things like clinical trials or peer-reviewed publications. Every attempt to do so has failed. There is no consistent results, there's no reliable underlying mechanism, and, most of all, it doesn't produce consistent outcomes. One of the more useful quotes from Tim Minchin is, "What do they call alternative medicine that works? Medicine." And that's exactly what we have with chiropractors. They're an alternative medicine because it doesn't work. It may be a great placebo, especially if you're an adult, unless, as mentioned, you're one of the unfortunate adults that gets stroke, broken neck, or death. Those, of course, being consenting adults. Not exactly what you can say about treatments given to infants. The final news we have for you this week might at least bring you some relief from the disheartening news of chiropractors laying hands to infants. It's the IgNoble Prize winners for 2022. The IgNoble Prizes are somewhat similar to the Nobel Prizes, except they are based on science that was done that has you scratching your head wondering why, followed by, that's actually really interesting. The range of winners this year includes some rather interesting candidates. Going straight to the gutter, we have ancient Mayan pottery showing the use of medicinal enemas and possibly enemas intended to intoxicate the individuals in rituals. This is based on two lines of evidence. One is the observation of what was on the pottery itself, and the other is testing on themselves. A study into what makes reading legal documents very difficult and therefore completely unable to be understood. The implications of constipation on the mating prospects of scorpions, and whether or not consuming ice cream rather than ice chips is of greater benefit for individuals who are receiving chemotherapy. There were further prizes given out for engineering, physics, peace, economics, and safety engineering, amongst others. The IgNoble prizes. Every year they live up to their name. That's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.